So let's check with the first property. A halogen oxidizes halide ions of higher atomic number. That means a halogen, I have taken an example, halogen Cl2 oxidizes halide ions. So I have written one halide ion also, X negative common, of higher atomic number. That means in the group after chlorine what comes? Atomic number of chlorine is 35. So next element it is bromine and then iodine. So the halide ion can be bromide or iodide. Now it oxidizes. I told you halogens, they will undergo reduction. So let's write the oxidation state here. Cl2 elemental form, it is 0. X minus minus 1. Cl minus minus 1. X2 0. Correct? If you want to balance the charge and atoms, I will write here 2. Okay, I will write here 2. So Cl 2 atoms, Cl 2 atoms, X2, X2. Charge is balanced, 2 minus on the left hand side, 2 minus on the right hand side. Oxidation state I have written here. Now 0 to minus 1. Decrease in oxidation state, that means it is undergoing reduction. Halogens are undergoing reduction. Minus 1 to 0. Increase in oxidation state, it undergoes oxidation. Halogen oxidizes, that means makes the halide ion undergo oxidation. One more example, F2 plus halide ion, it will give F minus plus X2. Correct? Again it is F2, I will write 2F2, balancing the equation, charge and the atoms. Okay, here it is fluorine, so what should be the halide ion? Having atomic number more, so halide ion can be chloride, bromide or iodide. Correct? Because they have more atomic number than fluorine. Now check, fluorine oxidation state is 0. Here it is minus 1 or minus 2 also, depending on the balancing what you have done. Here it will be minus 1 again, X2 0. Now check it, F2 0 to minus 1. Decrease in oxidation state, so it is undergoing reduction. Minus 1 to 0, increase in oxidation state, so it is undergoing oxidation. So halogen, it makes the other reactant undergo oxidation, that is oxidizes. Correct? So hope this first reaction it is clear to you. So the next property, decreasing oxidizing ability. Okay, we'll prove that by using some parameters and the electrode potentials, standard electrode potentials. So let's check that. So using the parameters, so I told you halogens exist as diatomic molecule X2. Just to balance it, I will write as half. So X. Okay. Enthalpy of dissociation. Enthalpy of change in enthalpy of dissociation. So X2 dissociate, split. What it will form? X, one atom. This atom, it will gain one electron. So enthalpy of EGE, electron gain enthalpy. Correct, I will write as Eg because enthalpy we have already written. Okay, so Eg means adding an electron to the atom, gaining of electron by the atom. So it will become X minus, because now it has gained one electron, it gets one negative sign. This one, on hydration, enthalpy of hydration, that means adding water, it will form X minus aqueous form. Correct. Just an example if I want to say is X minus It can be, suppose if it is HF, or you take the example of HCl, simple. HCl plus hydration, water. What you will get? H3O plus hydronium ion and Cl minus. So what you are getting? Cl minus, X minus, aqueous form, because hydration, water is added. Correct? Now, decreasing oxidizing ability. What is the oxidation state here for X2? 0, elemental form. What is here? -1. So 0 to -1, what is happening? Reduction is happening. So they are oxidizing agent, right? And what happens? Decreasing oxidizing ability. Correct? It undergoes reduction and they are oxidizing agents. Okay. One more thing. So these are the they are the parameters, like enthalpy of dissociation, enthalpy of electron gain, enthalpy of hydration. They are parameters. Now we can also explain it based on standard electrode potentials, the potential of an electrode at standard conditions. So F2, it has a potential of 2.87, chlorine 1.36, bromine 1.09, I2 0.54. All the electrode potentials, they have expressed it in volts, volt. Correct? So you can see for fluorine it is the highest when compared to the other elements. It is higher because I told you it has a more reduction power and it is a strong oxidizing agent. F2 oxidizes water to oxygen. So F2, so I'll write the reaction here. F2, water to oxygen. So it reacts with water. It will form HF and oxygen. So F2 is oxidizing water. That means F will undergo reduction but water will undergo oxidation. So what is F2 oxidation state? 0. In water, for oxygen, if you calculate, it is -2. HF for fluorine, it is -1. O2 in the elemental state, it is 0. So for F you can see 0 to -1 decrease. That means the halogen is undergoing reduction. But here water to oxygen, what happened? It undergoes oxidation. Correct? So proved. Okay. Iodide ions, it is oxidized by O2. See the sentence, listen. Iodide ions, they are oxidized by O2 in the presence of acidic medium. H plus I have written, acidic medium. It forms I2 and water. So which is undergoing oxidation here? Iodide ions. What did I tell? Iodide ions are oxidized by O2. Okay. Check the oxidation state now. I minus means it is -1. For O2 it is 0, elemental state. I2 it is 0, elemental state. H2O for oxygen it is -2. Now check for I. -1 to 0. Increase in oxidation state. So this is undergoing what? Oxidation. Oxygen 0 to -2 undergoes reduction. So here iodide ion, it is undergoing oxidation. And who is helping in that oxidation? Oxygen in the presence of acidic medium. Now suppose instead of iodide ion, I write for fluoride ion. Just the equation I will write. So F minus plus O2 plus H plus, that gives F2 plus H2O. Instead of iodine, I have written fluoride F2. Okay. Is this the reverse reaction? Okay. This will be the reverse reaction of first one. F2H2O, F2H2O, O2 is there, O2 is there, HF is there, hydrogen and fluorine, positive negative, they will combine. Correct? So this reaction can be reverse for fluorine. That is the first equation what we have written. We shall talk about the solubility of halogens in water. Okay. Solubility we are talking. So halogens, we know it exists as diatomic molecules. So it is F2, Cl2, Br2, I2. Okay. Bond will be like this, FF, Cl. So will they dissolve in water? No. The answer is no. Why it is not dissolving or not soluble in water? Because they exist as diatomic molecule and the FFCl, they are non-polar in nature. But water, it is polar in nature. Like dissolves like, correct? Polar will dissolve in polar, non-polar will dissolve in non-polar. So, when they exist as diatomic molecule, the FFCl, they are non-polar in nature and water is polar in nature. Correct? So, they will not be soluble in water. Now, suppose if they exist as F minus fluoride ions, will that be soluble in water? The answer is yes. Now why? If yes, why? If no, why? So yes, fluoride ions, they are soluble in water. Why? So fluorine, it gets -1 charge. How it is getting that -1 charge? When some element, it will donate an electron. Okay, suppose H, hydrogen, it has 1 electron. It is donating its electron to fluorine. Donating 1 electron to fluorine, it gets a positive sign. And fluorine, what it will do? It will accept that electron or gain that electron. It will get a negative sign. Correct? So, hydrogen fluoride, I can also say HF. It is soluble in water, or fluoride ions, they are soluble in water. What is the reason? They form hydrogen bond. And because of the presence of hydrogen bond, HF exists in the liquid form. Correct? Any species, if it makes hydrogen bond, it will exist in the liquid form. But for other elements such as Cl minus, I will write as HCl, HBr, or it can be Cl minus, Br minus. They do not dissolve in water, or there is no solubility in water. Why? Because there is no H bond and they exist in the gas form. Next property. Chlorine and bromine, they undergo disproportionation reaction with the water. What is disproportionation? Chlorine undergoing oxidation and reduction, bromine undergoing oxidation and reduction. Same substance undergoing both. Then it is disproportionation reaction. So let's see. So Cl2 and Br2 with the water, it will form HCl. Here it will form HBr. The second product is HOCl, HOBr. Fine. Now let's check how it is undergoing disproportionation. So here chlorine, the oxidation state is 0. Water, we will talk of oxygen, it is -2. We don't need, but still I am saying. We'll see for chlorine. So here it is 0, here it is -1. Here how will you calculate? Hydrogen it is +1, oxygen -2, chlorine we are finding, so put it as X. Solve for X +1. Correct. So here you can see chlorine from 0 to -1, it undergoes reduction. 0 to +1, increase in oxidation state, so it undergoes oxidation. Okay, so that means Cl2 undergoes disproportionation with water, proved. Second, Br2 0, HBr -1, here Br will be +1. So 0 to -1, decrease in the oxidation state, reduction. 0 to +1, increase in the oxidation state, oxidation. So we have proved this statement. Cl2, Br2, it undergoes disproportionation with water. Now these two are also acids. Name of this hydrochloric acid, hydrogen bromide, HOCl, HOBr. General names can be hydrohalic acid and hydrohalous acid. Okay, general names I have given, any one of the names you can write. So for the first one, what will be the name? Hydro, what is the halogen here? Hydrochloric acid, hydrochlorous acid. Second, hydrobromic acid, hydrobromous acid. Correct. Now what does this words mean here? Hydrohalic, why we can say like that? Because it is obtained in the aqueous form. Water is liquid, but here it is in the moisture form or vapor form. Okay. So the product, it is in the aqueous form. So this name, hydrohalic acid. Why it is hydrohalous acid? Because HOBr, that means OH group, hydroxyl group, it is attached to one halogen. Hydroxyl group, it is attached to halogen. So the name hydrohalous acid. So we have completed here with the properties. Hope you liked this video. Share with your friends. Thanks for watching and keep watching. Thank you.